I am Mandar Gadge from TYB Tech Division A, roll number EDA80. Today I am representing the topic optimization of loss function and best fit line using gradient descent as part of our subject exploratory data analytics. Let's begin by the understanding the concept of regression, how it helps us to find the pattern in data. Regression is one of the fundamental techniques in data analytics and machine learning. It used to predict continuous values such as predicting a person's weight based on their height or the price of the house based on its area. The basic equation of the regression line is y equal to mx plus c, where m is the slope and c is the intercept. Our goal is to find the best possible values of m and c that make the line fit the data points as closely as possible. The most common loss function for regression is the mean squared error or MSE. This formula calculates the average of the square difference between actual and predicted values. If the loss is small, our line fits the data well. If the loss is large, then the line is not accurate. So our task is to minimize the loss value. The main objective of the regression is to find the values of m and c that minimize the loss function j in bracket m and c. In simple terms, we want to find that one line that makes the total error as small as possible. This process finding the minimum value of the cost function is called optimization. But how do we find the minimum? That's where the gradient descent comes in. Gradient descent is an iterative optimization algorithm used to minimize the function like our loss function. Imagine a ball rolling down a hill. The ball always moves in the direction of the steepest slope until it reaches the lowest point. Similarly, in descent gradient, we start from the random values of m and c and gradually update them to move towards the minimum of the cost function. The idea is simple. Take small steps in the direction that decrease the error. The mathematical formula used to update the m and c in each step is this. Here alpha is called the learning rate, which controls how big each step is. If the learning rate is too high, we might skip the minimum point. If it is too small, the process will be very slow. The partial deviations tell us the slope of the loss function or the direction in which the loss increases. We move in the opposite direction to minimize it. The gradients m and c can be derived from the cost function and given by these formulas. These formulas help us to calculate how much the cost function changes with respect to m and c. By updating these parameters using the gradient descent formula, we can make our model more accurate with each iteration. The overall steps of the gradient descent algorithms are as follows. Initialize m and c, here for example both at 0. Then choose a learning rate alpha. Then compute the gradients partial deviation of j and m and partial deviation of j and c. Update m and c using the update rule. Then repeat this process until the loss value stops changing as much. That's when we say the model is converged. Once convergence happens, we found our best fit line. Let's look at the simple Python example that demonstrates this process. We first take some data points. For example, x is equal to 1, 2, 3, 2, 5 and y equal to 2, 4, 6, 8, 10. We initialize m and c to 0, choosing a learning rate of 0.01 and perform around 1000 iterations. With each iteration, we calculate the gradients and update m and c. We will also notice that value of m becomes approximately 2 and c is close to 0, which matching our data perfectly as given above. If we plot the loss function value versus the number of iterations, we will see a downward curve. This shows that as the algorithm progresses, the loss function gradually decreases and finally stabilizes at 0. This means our model has learned the best possible m and c. The visualization also shows that gradient descent is effective and reliable for optimizing regression models. So to summarize the key points, gradient descent is used to minimize the loss function. It helps us to find the best fit line in regression. The algorithm works by taking small steps in the direction of minimum error. Its fundamental concept not only in regression but also in training advanced machine learning models and neural networks. So, in conclusion, the optimization of the loss function using gradient descent allows us to find the line that best represents our data. Regression helps in prediction. The loss function measures error, gradient descent reduces that error step by step. Together, these concepts form the base of many analytical and machine learning techniques used today. Thank you for watching my video.